Hi everyone. So today I'm going to be explaining about end-to-end project, which is nothing but an AI-assisted smart healthcare system using the 5G communication. So how exactly this work and what is the project is about. So today I will explain you. It is very useful for BTech and MTech project work related. So how we have to make the contents, our certification, declaration, acknowledgement, abstract, and how to write the introduction, the literature survey. So these are the important chapters in our document, and as well as we have the PPT, so which is related to mention the college name details about, and in the coming to the next page, which is contains. So here we can mention the same thing: abstract, introduction, objective, problem statement, literature survey, right? So what exactly this project is about and how it works. So this project is nothing but the smart hospital monitoring system. So this project builds a smart hospitality, which is that uses the artificial intelligence and as well as the 5G internet to keep the track of the patient's health. So why we are using the 5G communication in this particular project? Earlier, we used to have the 4G and 5G communication, and there is in beside the patient, we have to be have the nurse to checking the patient how exactly the patient behavior is. So the 24 by 7 it is not possible. So by using this project, what exactly this does, the traditional healthcare method, which is manual monitoring, which is nothing but the slow prone and as well as the error based system. Like 4G networks can't handle the large scale, which is the continuous psychological data, and so it is not possible that data efficiently, right? So no seamless integration between the sensing devices as well as the data processing and storage. So it has a poor scalability. Patients at once, like, and data security concerns also matters in this existing system. So we are using this layers and the roles, like the iVote sensor nodes, which is used for the collecting the heart rate, temperature, blood pressure, and this fog nodes, which is here. Let me show this example so you can clearly understand. So this is the interface look like in the project. So we have the number of nodes, which is nothing but um, the how many nodes the patients and the patient's node ID. So if we select up to 100 we have, but we can select 60 or 50, anything which is uh, related for our decision, right? So what exactly this does? Data collects the iVote sensors that the patient's wearing, which is a smart health iVote devices. So it sends the data, and the data flows. How exactly this work is? See, when we give the number of nodes 40 example, and the patient node ID is 4. So as soon as we click on the generate smart health iVote network, it forms the network connection. So here I selected the 40 nodes beside the patient, and as soon as I click the generate smart health iBot network, I'll see the interface like this. So these are the nearest patient nodes in between the 40 patients. So this is the fog network, which is nearest fog network. Suppose I select the 26, so 26 is fog node 2 is nearest, so it will select like this. When you select this run AI algorithm, so we can see the hybrid model and confusion matrix, which is nothing but we can see the accuracy, precision, recall, and the F1 score. So we are using the two methods here, two AI models. So first one is a support vector machine SVM, and the second one is we are using the hybrid model. So hybrid model is exactly nothing but combining of the XGBoost and the random forest. Uh, it is a extension method, extension model, so which is called as the hybrid model. So here we can see that. our confusion matrix and predicted the true positive rate and the false positive rate, which is nothing but the blue and yellow, which is correctly predicted, and the remaining all are the incorrectly predicted. Right. And here we can see the hybrid model ROC and AUC curve. So what exactly it is? So here you can see the orange predicted line. So above this true positive rate, which is nothing but the correctly predicted. If we get this ROC curve under this orange color line, what exactly happens? It means it is a false positive rate incorrectly predicted. So our main goal is this curve, ROC curve, should be above the orange line always, which is the correctly predicted, right? So here we can see now you can give the node ID 4 or 3 or anything which is required. And in the screen, if we give the 4 ID network, so it will be predicted which is the nearest fog node. This is the server and this is the patient ID. So it will connecting the nearest fog node and it will send it to the nearest fog network packet server, and through that it is admin. So the green color which is admin, that is the cloud storage in the encrypted format. All the patient details and recorded which is in the encrypted format, it will be stored in that. Now we can see if we selected 6 or 9, so this is the nearest 9, fog node is the nearest one here, and it will send it to the cloud network. So here the sense, when once we click the transmit sense data, we can see the heart rate is 98% and temperature is 36 and systolic is 117, diastolic is 81. So like this we can see. So if we give the 4, it will be detect like this, right? And so this is the throughput graph, which is very important for us to see how this 4G connection is performing, like the mbps speed, right? And 5G throughput. So here you can see this 4G is a little less compared to the 5G is very high, and it is very beneficial for the remote areas, the patients which don't have the proper communication. So that's why we are using this 5G connection, which is important for us, right? So how exactly this work? Let me just go through this and explain in detail how we have to be executed. So the backend softwares, I use the Python 3.7.2 and the Node.js framework and the WinRAR zip file. So let me just open my folder. This is my project AI Smart Healthcare System by using the 5G communication, and these are the files which I am using. So what the data set is nothing but the patient data set, right? So here we can see in my patient data set. So here, so I have the these are the features that I used, right? So my database name is a Smart Health, and my patient data, so which is nothing but the where we will get the data from the patients, right? So we have the heart and temperature, systolic, diastolic, AI predict, and the recorded date, right? So the database, this folder, what exactly this folder does? Here it is, patient data set. Okay, so this is the patient data set. For the algorithm training, we are giving the patient data get predicted. So where do we get this? This is we got it from the Kaggle platform. Okay, so through this IoT sensor data, we will collect and data that a patient is normal or abnormal, we have to be checked, right? So I'm using here DJANGO framework, which is used to create the front end HTML and CSS framework. Okay, so compared to the Flask, it has a less features. And the Django has more features. So here, let me just run this so you can better understand. So let me give this CMD command prompt. Okay. So here we go. And now this here, before that, let me just explain exactly these folders about and health app, why this static folder and this template is used for. Right, static folder, we will create it from the user side externally. We will add the static template, except the static remaining all are based on command we are getting in the static folder. Like we use the CSS and HTML. And view folder here, views. You can see this views. So this main application front we will see in the view folder. Right. So health, when we open this template, like we have the different HTML pages in the front end, right, in the Django framework. So what it exactly you stands for the MVD, which is nothing but the models. So models, views, and this templates. Right. So models is used to handle the database, and the template is used to get the different web pages, and model with folders data, which is nothing but the data NPY. So the data patients is encrypted format in the cloud. In real time, it is very costly to purchase. So we are using a dummy cloud. Right. So we use the MySQL for storing our database. So to create this database, we as we use the smart health database, right, where it is all the patient records will be stored. Okay. So we have this. You can see here. Once I go back and let me show you this manage health, how exactly this work. Okay. So here, manage health folder app and templates which we are manage run server and run simulation. Why it is run simulation? To get an interface run. Okay, so run server folder to access the patient data, and the screen folders like a step by step process which is there in our program. Right, simulation folder is used that project entire logic which get stored in this, like IoT network simulation related code. Right. So what I will do as I open my CMD, okay, so I have to give here the command which is nothing but the I have to be run python simulation dot py. Okay, so let me just click on enter. So what exactly it does, it will open the interface. Now we will see the interface which we just seen in our presentation. Right. So it will take some time, but not to worry. So it depends on our system speed. Right. Okay, so here we go. It is giving the option to select the number of nodes. So let me just select here something 31. Okay, so node ID, it is depend on our wish. So we can select 4 or 5. Then we have these generate smart health IoT network. So I have selected the number of nodes 31. So nodes is formed already. How many nodes we have? 31. So I have given here 31. So 31 nodes are formed. Okay, now I'll click the run AI algorithm. Okay, so let me just click the run AI algorithm. You can see here the hybrid model. So blue and yellow, which is correctly predicted, and which is incorrectly predicted 5. So these 5 files will be get generated and stored in our folders. Okay, so now we can see the hybrid model ROC and AUC curve. It is above the orange line, so it is a true positive and correctly predicted. Right. So you can see here we have used the two models. First one is SVM, support vector machine. So we got the accuracy of 86%, and the second one we have used the hybrid model, extension model. So which is combining of random forest and XGBoost models. Okay, so we got the hybrid model. It is an extension by using these two algorithms. So here we got the more accuracy compared to the SVM 98.75, and precision also you can see 99.28, and recall. So F1 score is nothing but 97. So it is giving the highest accuracy compared to the SVM. So now let me click on the transmit sense data. So what exactly it does? Transmit sense data is nothing but you can see it is checking the nearest fog node. So this is the nearest fog node, so that's why it is selected the fog 3. So fog 1, fog 2 and fog 3, which is nothing but the patients. Here how many patients we have, and we have given the patient ID like 31, so it is N4. So here node ID I have given the 4, so that's why it is selected like this, transmit sense data as soon as I click. Okay, so here fog nodes is nothing but the nearest server packets, and it will which is be used for the data encrypted. We have to be have the patient's records, all the details that no one can see and access. So for the authorization to encrypted format, to keep the details safe, only the doctors can access by login the application, right? So that's why we have to be put it in the encrypted format, so these fog nodes will be helped and the data will be sent it to the cloud. Okay, so as soon as we click on the transmit sense data, we can see the patient heart rate is 77, temperature is T8 and 182 normal. So AI predicted this one, this patient has a normal condition, right? Fog node is, you can see here N4 to N3 like this we have seen, right? So now what I will do, so let me just go to the again my folder, AI folder, and here you can see I have to be run my application. To run the application, what exactly we have to do? So as just now we have seen, like AI predicted the normal, selected the sources for 3 nodes. When we add the systolic diastolic, we will predict the BP, which is like 120 by 80. Now simulation is completed, so we will just minimize minimize it, and here we go. Okay, so path address bar, we can in this, once again we have to be give the path address bar. Let me just minimize this as well, and here let me open this command prompt once again, and here I have to give python space, which is nothing but the man. As I'm opening my application, so let me just give the command as manage.py run server. Okay, so here we go, and so what exactly it does, now localhost is created. We will copy this link address and paste it in the new browser, and we have to be add the index.html. So let me just copy this, and I will go to here new page. Here I'll paste it, and here I have to be add the index.html and click on enter. Okay, so this is, we will get the HTML homepage application. Now we will access the patient data by clicking on the access IoT smart health data. Here we go, we see. Okay, so here you can see, as by default it is selected the 4, as I given the patient 4. Okay, so now we will access this I vote, choose I vote, and let me just click here to see the patient details, which is in the coming to the tabular format or not. So here you can see the 40 records we have, so let me just select the 4 and click on the submit. So here I have selected the 3 times 4, like you can see the date, today's date is 29th 7 and 10 6. So it is generated the patient heart rate is 77, and this is the temperature, and this is the BP, and diastolic systolic, the patient condition is, the algorithm predicted that patient health is normal. Okay, so this is how we got the details in the tabular format. Okay, so whatever we give the patient node ID 5 or 6, it is depends on us. Okay, so backend, how exactly it works? This simulation folder, like you can see here, here we have the simulation folder. Okay, so once we click this simulation folder, so we got all the details. Okay, so why this Python libraries are used. Okay, so it will be opening in the VS code. So we have the predefined libraries to get the perform for the different task, and the interface which we are using, and here we go. Here we see. Okay, so it is still taking time, no problem. So let me just why this how many libraries I have used, and what exactly it does. So let me see this first. Yeah, here. So we have used the tkinter and numpy pandas. Math is used for the mathematical calculations, and random is used for the generating the patients. We can choose the randomly, and the threading and the collections. Tkinter matplotlib is to see the our visualization. Numpy to convert the data into the array format. Okay, so this is how we will get entirely, right? So let me just explain for the training purpose, like this. Why do we use the tkinter? Like it is lightweight and sklearned to see the different ML algorithms, which one will support. So as of now, we are using only SVM and hybrid model, which is the combining of the XGBoost and XGB classifier. So here for training purpose, we have used the SK scikit-learn, and here. Okay, how we have to be train the data. So X and Z, independent and dependent variables, how it exactly works, right? And I also use the py mysql, so Python mysql, which is connected to the Python with mysql data platform, and the global variables, which I use these global variables to use the inside and outside the functions by. Okay, so this is how we got our hybrid model algorithm, and I have used the different uh, functions. First is nothing but the calculation metrics to, as just now we have seen, the accuracy, precision, recall, and F1 score, which model is the best for our predicting the patient's health records, and which gives the highest accuracy rate, right? So for everything, like we are using the saving and record method. So it is stored the patient data. We mentioned the patient data set in our algorithm, right? For everything we created the functions. We got the graph, you can see in this 60 line how we have trained the data and splitting the x and y. 20% is for the testing purpose, and remaining the 80% is for the training data and SVM, SVC. So it is SVC, which is used for the data encryption format, right? And the XGB classifier, this is our algorithms, and we use the different get distance method. So how exactly, with the help of these buttons, we can see the clear interface for everything, as we created different buttons throughout the graphs. Defines the comparison and 5G and 4G networks, the Mbps speeds, how we will get that, right? So this is the graph function we have used, and create the fog, get distance and fog. Okay, so it is slow, but not to worry. Let me just explain this, how different functions are useful in our algorithm. Set location and generate the network. How this fog node will be connected to the admin network. Fog node is the nearest network which is connected, and encrypted format, and decrypted once the doctors has seen the patient records. So that will be decrypted, and they can by log the application, the doctors can see the patient the health details and the condition, right? For that purpose we are using. And so this is how our all the functions, buttons, networks, by using the run simulation we can see, right? So now let me just it is still in this start data transmit, as just now we have seen this in our data transmit simulation here. As soon as we click this format and sense transmit data, so okay, it is still stuck. But here we can see as soon as transmit sense data functions we have used in our algorithm, right? In the decrypted format, save records communication. So how MySQL is used to store all the patient records and get all the details, we are using it. So let me just go here and in the search here, I have to be open the MySQL command line. Okay, MySQL command line, you can see this and open this, we can see our data set, how exactly it will work. So you can set the password and give the password what we have mentioned here. MySQL command line, okay. So we have a specific syntax, as I have shown here. Okay, so our database name is smart health, so we are using this smart health. So let me just open here, and where is my command line, my SQL command line prompt here. Let me give this. Use smart health, right? Use. Okay, so now I have to see the all the patient, how many patient I have selected. Just now I showed the patient, fourth patient ID, how exactly. So how many I have selected, how many records we have seen, how many patients details we have seen, we can see here. Okay, from select star from the our patient table name is patient data, right? So patient data here. So you can see the recorded date and the patient, all the details here. So today I have just shown this one, A90, the fourth one, which is nothing but the our timing. So everything it will be recorded as we have seen here. Now we will go to the application. Okay, so how we will go to the application here? So by this is our application interface. We have the home. In the home, you can see here by using the health folder apps. Entire the project logic. Okay, so this is how the home interface look like, and when we click on the access IoT smart health data, so these options will give us the whatever we can select, we will get this. Okay, so as I have selected the fourth, so I have to be access the fourth only, so I will get the details, how many times I have seen this patient ID. By using this patient ID node we can see here. And to talk about this, by using the health app folder, like entire project logic, once we open this views. Okay, so let me go to the views here. This is a Python source file. Let me just open this, and here how exactly we have imported all the libraries DJANGO framework by using. So you can see here all the difference and formats. It's still taking time, but it will be, yeah, it will come up. It is same like the front end application, the DJANGO framework. Okay, so we use one function like. Here also we have used the encrypted and the decrypted format. You can see the communication. Okay, still it is loading. So these are the functions and the libraries we have used, and AES encrypted and DES, which is for the decrypted format. Right. So these are the functions we have used. Access IVOT actions to get all the patient records in the tabular format. We have used AES decrypt and AES encrypted, decrypt and encrypted format to check the patient details all in the encrypted format, which no one can access access except the doctors, right? So they can check the patient details. Okay, is nothing but all in the tabular format we have used. So we have mentioned here. So access I vote and these are the we have used the less functions here in our Django framework, right? So this is how our entire project to look like, and the frameworks which we have used. And here you can see the uh, I vote action functions, the particular format request, and we have used index.html in our application. Right. So once we open this, let me open this. Here I have selected this HTTP ID and I have given the index.html. So that's why when we got that, this is the interface we can see. Okay, so this is our end-to-end entire project. If you really like this, please like and subscribe. Thank you.